Industries everywhere, from automotive engineering to cinematic production, are rapidly integrating real-time 3D engines into their core workflows. This shift has created a global labor deficit, a critical demand for a 3D native workforce capable of operating within these simulated environments. Historically, specific prerequisites have limited the scale of this workforce, narrowing the pipeline to those with advanced computer science degrees and mastery of traditional CAD software. These legacy software pathways involve steep learning curves that prevent institutions from producing the volume of creators the market currently requires. To meet the demands of modern engineering and media, institutions are exploring a new educational architecture designed to bypass that traditional CAD bottleneck. This framework is known as the Continuum of Pedagogy, a strategy focused on achieving equity and technical scale through scaffolded learning. The continuum maps progress along two axes. The x-axis tracks the student's journey through the school system, from primary to tertiary education. The y-axis measures technical fidelity, plotting the transition from initial digital play toward professional architectures. The pathway utilizes the Epic Games ecosystem to guide this growth, moving sequentially from LEGO Fortnite to UEFN and finally into the full Unreal Engine. This scaffolded approach allows learners to acquire complex real-time 3D skills while minimizing the cognitive friction usually found in professional software. Phase 1, designed for primary and middle stage learners, utilizes LEGO Fortnite as a sandbox for constructivist learning. In this environment, students develop spatial awareness through direct interaction, rather than the abstract vector manipulation found in traditional drafting tools. Students practice environmental stewardship by navigating digital biomes that simulate real-world constraints, such as climate impact and resource scarcity. These multi-user spaces naturally encourage collaborative logic, requiring students to solve problems and manage projects as a team. The process of building a shelter, testing its durability against simulated physics, and refining the design based on those results provides a practical introduction to the engineering design cycle. This gamified system establishes the baseline cognitive requirements for 3D navigation before students encounter formal technical instruction. Secondary education marks the transition to Phase 2, the Unreal Editor for Fortnite, or UEFN. UEFN operates as a low-floor, high-ceiling platform, providing professional-grade creation tools within a familiar, high-engagement interface. Spatial logic converts into computational thinking through verse programming, used to script game logic. By defining rule sets and mechanics, students master UX design. Finally, importing custom 3D models builds technical literacy, bridging the gap between simple play and asset management. This phase represents the pivot point in the continuum, where the student shifts from a consumer of digital content to a creator of interactive logic. Phase 3 integrates senior and tertiary learners into the full Unreal Engine ecosystem. At this level, the focus moves beyond game mechanics toward industry-standard virtual production. Students master real-time rendering, gaining a deep understanding of how light, physics, and cameras interact within a digital space. Using the engine as a virtual film set allows for non-linear production workflows, mirroring the techniques used in modern cinematic storytelling. Reaching this stage signifies a synthesis of technical skills, preparing the learner for immediate entry into the professional media and production workforce. These skills extend into industrial and scientific applications that go far beyond entertainment. A primary example is the development of digital twins, virtual, real-time replicas of complex physical systems. This technology is currently used for data-driven urban planning, simulating complex city grids, and creating high-fidelity medical visualizations for advanced research. Achieving this level of architectural capability provides students with a versatile skill set applicable to various sectors of the global digital economy. For educational institutions, aligning with this pedagogical continuum addresses several long-term administrative goals. The first is future-proofing, ensuring curriculum remains relevant as real-time 3D becomes an industry standard. The second is equity. Free platforms lower financial barriers to high-end vocational training. Finally, this pathway facilitates cross-curricular integration, merging STEAM subjects into a single workflow. Adopting this framework democratizes access to specialized career paths that were once restricted to elite technical programs. The journey moves chronologically, from foundational spatial play to intermediate scripting, and finally to professional rendering and synthesis. This strategy provides the next generation with the systems-level thinking required to navigate an increasingly simulated professional landscape. This continuum transitions students from passive users of technology into the architects of complex, interactive worlds.